Welcome to our Going Green podcast. We're looking at what's happening this week in sort of extreme weather this week and all the events. I'm Philip and this is Paul, and we're going to have a little discussion over the next half an hour or so on what's been going on this week, because an awful lot has been going on this week. We hit the headlines really sort of just a week ago with what was going on in Germany.
Well, Germany, the Netherlands, Belgium, uh, basically it's along the Rhine. All this catastrophe, all the major flooding happened.
And not just the rivers, but also the whole land was getting flooded,
Well,
and the reservoirs were all filling up and then bursting.
Yeah, and they had major dams problems, having issues. I can't remember what's the other few other things, all the erosion. But that's not the only place it's been flooding. We know that China has been flooding for a while. However, just recently, almost the heaviest rain in the what?
They said 1,000 years.
Yeah, well, they've got charts dating way back, because they've actually got recorded history. But you think Germany's amount of rainfall fell in Germany was what, 3 days or something?
And the same amount fell in China in 1 day.
In 1 day,
which is sort of absolute phenomenal amount of rain. I've never I don't think in this country we can comprehend that. And looking at the sort of the tubes, underground system, their tube system of people wading sort of chest high or neck high even.
Yeah, it's like that we saw the subway train that was just people, the carriage was just filling up with water, and
and they couldn't get out. There's nothing they can do apart from hope and pray that it wasn't going to sort of kill too many. The latest data I've seen from China is officially 33 dead, and they said tens of thousands displaced.
Yeah, it's horrific, and all this is a consequence of more weather, but of course the weather is affected by the temperature increase.
Well, it is this climate change that people were arguing it's not happening, and now blatantly we can actually see it is happening all the time. Germany's a good example, and I think if some people had sort of accepted climate change was happening earlier and they'd invested some money in prevention, then that would be an awful lot cheaper than the cleanup job they've got, repairing all the infrastructure they've got. And then, of course, also having to put in place all the things that they should have done before this disaster.
Yeah. And you can't really say anything beyond, prevention is so much cheaper than rebuilding, replacing.
And of course, how much does a life cost? This is one of the other problems that we really face. How much money is a life worth?
Yeah, it's terrible to say, but these things are happening.
Yeah,
and it's not the fact that these things are happening; they're not happening elsewhere. They're not happening in the third world, or even they're happening to us. They're happening right here in the neighborhoods. You think, what was the last time England flooded? It was in the, that was only, year ago?
2 years, I think.
Maybe
yeah.
2, yeah.
And that's when Somerset flooded.
That's when Somerset, yeah.
And we have East Anglia gets flooded, because they're the flat plain bits that, you would expect are going to actually flood. And surprisingly, they do. Well, not every year, but they do occasionally. And these occasionally seem to be happening more often.
Yes. Well, they were saying in relation to the German storm and the one in China, is that the storm, when it goes over land, it gets slower. So, because that's how it goes. And so what they said is suddenly the storms are slow, they go really fast, and then they hit the land and they go extremely slow, and that slowness gives the storms time to absolutely downpour all the rain everywhere, and they were saying the time for a storm was over the places is actually increasing, because it says it's more denser, because of course there's more rain in it, more water, because more water's evaporated off the ocean surfaces, into it. And so, it's more energy in the system. So when it falls, you're not getting just a little bit of rain. You're simply getting nearly 3 or 5 times the amount of rain that would have been there.
Yeah. And it's not just the slowness is caused not just by the movement over the land. It is the global warming is changing the patterns of where the weather is happening. And that's also contributing to the slowing down. And it, according to reading, the Met Office, it is the slowing down of those storms, as you said, that's causing the big problems of more water. So we've had big floods in Europe, but we're also looking at floods in Bangladesh. Some of that's related to sea rise. We're looking at sea rise also taking place around the Baltic. We're looking at not just rain, sea rise, but we're also looking at that extreme heat that we've had in, well, they've mentioned the far north, really, isn't it? Canada, but also circling round up into Siberia, and the effect that that's having on things like permafrost.
Yeah, it's one of those things where we're seeing not only all this weather, but we're seeing where there's lack of weather, where there's all this heat from it. Speaking of heat, did you, I know because you read it the same, but this is the first time the Met Office has actually given out an extreme heat warning or heat wave warning, as opposed to a low level or normal heat wave warning, which is sort of. And then I asked the question of, so what's the difference between, I say, a normal heat wave and an extreme heat wave? Right?
Well, I'd like to say temperature, but
well, it is a temperature, but it's not quite, because obviously a heat wave is a significant high temperature over, I think it's something like 3 days. It's something that you've got 3 days. So, you've got to say it is the extreme temperature. An extreme heat wave is the same period over the 3 days where it would be hot, but it's actually the jump of heat. We went from nearly
20 to 30,
almost to 30 overnight, where previously we would have gone from 25 and then reached up to the 30.
And it is having this sort of 30 for several days. And although I could take my mum as an example, my mum says, 25, yeah, that's quite pleasant. I can do things. At 30, she starts keeling over and saying, oh, this is too hot. I can't do anything. And she notices that she's actually drinking more, which is good. But she's lucky. She lives in a house where she can open the front windows, the back windows, and she can get a draft going through the house. And some people can't.
Well, no, unfortunately not. But I think over the last couple of days, looking at the wind patterns, it's actually been not that windy.
Yeah.
Well, at least here hasn't been. It's which meant that although you opened the windows to create this sort of draft to allow air to move through to help cool things down, it wasn't happening.
I always laugh when people get the fan out and they just say, oh, it's lovely and cool. And it's not. I've done this experiment with students. You show them the temperature of the air going into the fan one side and the fan the other side. It's exactly the same temperature. And you can only look at the coolingness, which is evaporation of sweat on your body that makes you feel a little bit cooler. Having said that, we had the fan out yesterday. We had it in our kitchen and we had it in the lounge.
Yeah.
And we needed it.
Yeah, but the critical thing, of course, there, apart from the helicopter above, is that the fan, is it nearly a foot diameter? Just over.
nearly 2 foot.
Oh, okay. Well, that's
Yeah,
and so it moves a heck of a lot of air moving through. And that's fine. It's no problem. It's almost basically an industrial fan, whereas the whimsical sort of commercial fans just do not pass enough air or push enough air around to actually make a difference, which
yeah.
is the
I,
crucial
I
thing.
I use this fan, to be honest, for science experiments to create sort of more of a wind tunnel effect and actually drive turbines when we're doing electricity generation. And so this fan does move an enormous amount of air, and it's much more effective than seeing a little sort of desktop 12-inch, 14-inch fan trying to move some air around.
Yeah. And that's crucially the important point is to get air over your body, which then allows the sweat to evaporate. And that's how people cool down. And unfortunately, those who aren't drinking enough water get dehydrated because, of course, they're sweating lots, and that leads to more problems and into heat death.
Yeah. Well, since I had kidney stones, I've been good and I've been drinking a fair amount of water each day. But in this heat wave, I've been drinking nearly double that amount of water, and I've wanted to drink it. And I've probably therefore needed to drink that amount of water. And I know that I've been sweating a fair bit because I had a shower, and having came out of the shower, half an hour later, I'm still desperately trying to think about putting my shirt on and being wet. And I know somebody else who had exactly the same problem. That was actually everyone in the family, wasn't it? Going round at different
Yeah,
points of the day.
yeah. We took. It's one of those things where it was overwhelming, that sort of just needing to cool down, but it wasn't. It was trying to wash all the muck on from obviously from the sweat off to start and make clean sweat essentially.
Yeah. It's something we're not used to in this country, and this is where we've mentioned before in other podcasts that buildings are going to have to be changed. We need to have better ventilation in houses, or just better design to allow the heat to be sort of the houses basically to cool down easier, and basically keep the heat in the winter. This is what my mum said when she got up. She said, when I got up, it was 27 downstairs. Outside, it was only 21. But the heat was built up in the bricks and they were staying hot. When I went to bed last night, I happened to look at the thermometer in the bedroom, and it was just a gentle 31 Celsius.
Yeah, about right.
And I'm thinking, sort of, we don't exactly want the thick duvet on. We do have a one tog thin duvet that we passed on. And even the sheet was passed on for a little while because it's just sort of too much, because any little bit of breeze going over you was sort of helping the sweat evaporate and you cooling down.
Yeah, and that's the important thing, is to have this, to the sweat, and people sort of laugh about it, but that's how our bodies are built to cool down, you know, and if you stop sweating, which is, that's a major problem, and basically you can overheat, and then, well, you sort of don't do so well after that.
No, it's called hyperthermia. Not something we come across too much in this country, but it is something that we're coming across more. That's why we've got the extreme heat warning, and it's what other countries are suffering, and people do sort of die in the heat if they can't cool down. Generally, I suppose in Europe, we're very used to cooler temperatures, it being cold and wrapping up. We don't get very many hot days, and when we do get some hot days, people are rather stupid. They do tend to rush to the beach. I read on Facebook one of my wife's friends went to the beach and said it was lovely. It was warmer than a lot of Europe, and since we're having to do staycations largely this year, yeah. But she said she decided to go and put her foot in the sea, North Sea, I will add it, this was.
Yeah.
And she said she got as far as her ankle and then decided that it really was still, freezing out there. Sort of, she couldn't see the icebergs, but she was sure they were there.
I mean, yeah, but you look at the temperature. What the North Sea's 4 degrees?
No, it's a bit warm.
Oh, okay. Sorry, my fault. It's a bit warmer, but it's about that sort of temperature. And usually people like
Probably 10, 15.
right, yeah. And but the major thing is people go in there to get that temperature addition to basically for something else to absorb the heat, or so they can have the circulation of the blood to get that coolness because they're cooling down inside as opposed to sweat. But
Yeah. But then you read what the RNLI say, and their warnings have been: you get hot on the beach, you decide you're going to cool down, you rush into the sea, you swim around for a moment, but then you suddenly realize that cold has hit you, and you can actually lose your breath. You can not quite stop breathing, but then you've got to turn on your back and you've got to try and deliberately regulate your breath so that you can then swim back to the shore.
Yeah, they were talking about winding yourself. I think is they were talking
Yeah.
about is the whole thing. And yeah, it's one of those bizarre things. You see, we're not meant to adapt to sudden changes in regards to you just think why reptiles are cold blooded. You always hear that they go out in the sun to heat down, but what they do is
Heat down, heat up.
heat up.
Yeah.
Sorry, and then they go in the shade to cool down. And they have to regulate their body temperature by doing this pattern of heat up, cold down. Whereas us, we've got this lovely system called homeostasis, and that regulates our body temperature. So any sudden shock to that regulation creates a sudden shock elsewhere.
And causes a lot of problems. And it is that people aren't used to it. That we're not. If you live in a hot climate, you're used to dealing with it. Whereas here, we get a nice sunny day, it's quite warm, and people then decide to go out and be stupid. I have to go out and wear a hat for some reason. It's sort of, there is plenty of hair on top. It's just that, as my wife seems to point out, it seems to be fairly finely spaced.
It's finely spaced.
Yeah. And just going out down to the shops, I can burn my head. Did that on Monday, and I went out shopping. I wore a hat, and only for a little bit of time did I actually have the hat off. Yet, in that time, because it was sort of noonish, I managed to sort of get my head looking a little bit
Well, it was
red.
Yeah, getting towards a tomato.
Yeah.
But that just shows you critically, it's not the sunlight doing it. It's when you're going out and in what part of the day you're going out, if that makes any sense. In regards to the problem you're receiving is the damage, the essentially the burning, which is why your head's going red, is because of the UV light.
And the UV's been very high because you look at how blue the sky's been. We've got lovely blue skies, and the lovely blue skies certainly mean that there's little water vapor in there, and there's less sort of absorption of that UV. And we can see from the Met Office, they put the warnings, UV levels at very high, and going out in the noonday sun is typical of mad dogs and Englishmen, isn't it?
Yeah. But, and then you hear about all these people who want to get all the nice tans and things, and they go in these tanning booths, and they sort of have major problems later down the line with skin cancer because of this UV, which is normal when going outside. You look at people who go outside and get freckles.
Yeah.
And freckles is caused by damage, skin damage caused by UV light.
Well, you lived in Australia for a year in Perth, and there people didn't seem to go out in sort of next to nothing, did they?
No, it was one of those things where noon was a critical time, where almost like the Spanish siesta. Fiesta, siesta,
Siesta.
siesta. Right. Basically, is you take the noon time off because it's so unbearably not necessarily hot, but high levels of UV, which is also problematic. And so you take the times off, and therefore you just work in the evenings when it's lower, less risk, and obviously cooler, because that's how Spain works. But it's the idea of, don't go out in the the massive sort of sunlight, when it's all clear and it's strong at the strongest point, like afternoon, is to go at other times. Or if you have to go up noon, it's to take precautions. It's silly things like lots of the clothing out in Australia is actually UV rated, which seems a bit daft, but obviously UV light breaks clothing down and plastics down, and so they're going to be tolerated, have the clothes tolerant to the high UV levels.
Let's move on to one other thing that's associated with this heat, which we mentioned, was the heat's been going up fairly high. We've seen quite a lot above the sort of up Arctic Circle way, going really high. We've seen in Canada, place Lytton, that got to 49.6 Celsius.
Something like that.
And around the other side in Siberia, that also getting above 30. I don't know what it was. And that causing permafrost to melt. And that's causing a lot of greenhouse gas emissions.
Yeah, and it's one of those things where you look, how much permafrost is there? And the answer for it was in the Arctic Circle was 65% of the land covered in this permafrost.
Yeah.
And you've got to understand what permafrost is. Permafrost is
Wrong one.
yeah. Permafrost is the soil that's actually frozen. It's not ice or anything, it's actually soil that's frozen. So
yeah, because all the ice in there has actually just sort of frozen the soil as well. And how long ago was that frozen?
Well, the continuous front could have been frozen for approximately nearly since the woolly mammoths were roaming around, because that's what they say.
Yeah, the Ice Age, the last Ice Age. And with the last Ice Age, that's a long time ago, and all that carbon is locked up in there. And soon as the ice starts to sort of melt, it sort of doesn't come out as nice water, it comes out as mud. And that mud is not just soil, but a lot of organic stuff in the soil. That is then sort of, well, it's in water. And then it tends to sort of bubble and give off methane gas, doesn't it?
Yeah, it's not quite. So all this muddy water flows in, and all the sediment then flows down to the bottom of ponds, and then in the bottom of the ponds, that's where these organic materials decomposing into things like your methane and your carbon dioxide.
Yeah,
and then
it's anaerobic respiration.
Anaerobic respiration, and so from those puddles, you see everything bubbling off, and that's how basically we see the crease of things, and obviously there needs to be work done to cool the world down, the earth down, to keep the Arctic cold. But an interesting thing, daft thing I heard, that what is the Siberian climate scientists' idea to save this permafrost?
And the idea that I was hearing about for this is actually to try and get more animals in there. The more animals, they compact the ground, and that stops the air and also therefore the heat getting down into the soil, and therefore it keeps it colder.
Yeah, which is one of those odd things you think about, sort of, why surely we should be sort of, putting ice bags on it instead of actually putting animals on it. But it is one of those solutions that is counterintuitive. The animals are doing the treading the ground and all those sorts of things, which is actually more beneficial than, putting in, say, an ice pack on it and keeping it cool that way.
And so I think we've got to think at new ways, out of the box ways of trying to keep things warmer, cooler, if we're going to do something. So the permafrost, then it looks like, taking animals, and there aren't that many there, but trying to increase the number of animals that are there to sort of compact the soil more to keep it colder. But what else can we try and do to sort of help this? Well, if you're down in China, China is one of the world's largest polluters. And if they can start turning that around a little bit, then China doesn't become the largest polluter. Therefore, they're not making as much carbon dioxide, as much methane, as much. And that hopefully would start to turn the tide, and then they wouldn't have the problems of these big floods and heavy rains, and these heat domes that we've seen and heard about in various places, and associated, of course, with these heat domes, the heat building up and drying the forests out. The slightest thing that happens, then you get forest fires, like we had big ones in Australia last year, and it seems it's the USA's turn this year.
Yeah, yeah, and it's one of those things where things just turn into a powder keg, and that's where they start lighting like tinder. And then you have to, as I said, you have to then react to them instead of preventing them, which of course is the crucial part.
And the winds are blowing sort of towards the sort of eastern seaboard. So states that aren't on fire are sort of suffering the amount of smoke. And I saw pictures of New York, Pennsylvania, where we have a friend, and it's sort of, well, how bad was it? It was sort of this smog that you sort of thought it was sort of,
Yeah, you look at these pictures where you see pre-pandemic Delhi, pre-pandemic China, all those sort of places where there's huge amounts of smog, and you just wouldn't think about a place like New York, which has lots of rules and regulations about pollution and air quality and all these sorts of things, to be smothered in this soot, essentially. But it's not New York producing the soot. No, it's just that the fires have carried, and the winds have carried the smoke from the western side of America all the way to the eastern seaboard.
yeah. So we're seeing the sort of heat causing more and more damage, and the floods causing more and more damage. And it needs people to wake up. And I'm hoping that the floods in Germany may spur Germany on to say, we ought to be doing a lot more. Instead of doing this by 2030, we need to do a lot more by 2030. Hopefully China might see that they're producing a lot of this pollution. They can do something. America also produces a lot of pollution. I know now they're on their hobby horse saying they're doing this, this, and this, but they're rather late to the party.
Yeah, they weren't doing it for the last 5 years. Now, we know why they weren't doing this for the last 5 years.
Didn't happen until a couple of weeks ago,
exactly.
a few weeks, yeah.
But the problem is, we need to have been doing what we're doing now, is all this clean energy stuff, this going green, all that sort of, 10, 15 years ago, when people were shouting about it and no one was really paying attention about it. And it's only now that people are saying, told you so. And unfortunately, that's the consequences that they're living in.
We've known about this happening for a very long time, and people have just said, yeah, okay, fair enough. Yeah, it's not happening now. It's not nothing happening. And suddenly now it is happening. People are seeing this happen. And I worry how late we are to try and do something. We're talking about stopping the heat rise, getting up sort of 1.5 degrees. I think we ought to be talking about trying to get down 1.5 degrees.
Yeah.
And that would be really frightening to see how that would sort of change what we need to do. Well, this has been our podcast, Going Green, talking about extreme weather for the last week or so and where it's going to take us. Next week, we'll have a look at some more topics on climate change and how it's affecting you, me, and especially Paul and Philip. So it's goodbye from me.
And a goodbye from you.
Yeah, okay, we're working on it. Bye-bye.
Bye.